What's up, boys? Been a minute. Let me see if I'm live. Boys, been a minute. Okay, so today we're back on what is it called? Our little blockchain program. So right now I'm working on transactions. I need to understand how asymmetric encryption and decryption works, so I can kind of implement it at scale. I'm gonna read about it like in the off page really quickly. I'm gonna ask how it works. Basically, I need to learn how a public and private key thing is generated and how it works exactly. Um, RSA is like the common one. You could use ECC. You could use Algamo, non-encryption by itself. Okay, what's the most reliable? Okay, so RSA is like compatibility with old systems, and ECC, ECDH is like the newer stuff. Um, I, I mean, I'm not gonna work on the math anyways, so I'm just trying to see if it makes sort of sense. So I'm gonna try doing the ECC part, elliptic curve cryptography. Let's see if there's like a library for that. Um, oh, BG in building the library. Okay, it's like a huge. Okay, let's just. You know what? Let's just do RSA. I think I can start with RSA, and since this is a yeah, OpenSea SSL has RSA, so I'm gonna start off with that. I'm just pulling up the OpenSSL documentation, and then I'm gonna see if the other people who are working on this can get the other stuff working. So where am I? Yeah, here's where I am. So I can so we can include IO stream first, and then include OpenSSL slash rsa.h into main over here. I need to look through how this works. So the following functions have been deprecated, yada yada yada. CRT parameters. What is this? Um, ah, examples. The command processes public or private keys in various forms, yada yada yada. File name, I don't really care about this. In C++, modern SSL, high level EVP API for RSA key generation. Okay. So let me just write some notes over here. Let me see. So the way I kind of understand it is, I don't really get it fully. So you have a public key and a private key. You use the private key to sign something, and you can verify it using the public key. Is this how this works? That kind of makes sense. How does public and private key work? The public key encrypts messages while the secret private key unlocks it. Okay, I see. So it can encrypt a message sent to the owner, or it can verify digital signatures created by the private key. Okay, so it can do both. Okay, so I need to understand how to use the OpenSSL EVP library. PKey, RSA, cryptographic. If your RSA is implemented, that provides RSA keys. Okay. RSA, when generating RSA keys, the following key generation parameters may be used. I don't know what any of this means. What? Okay, I guess we have an example. EVP. So I don't know if these things are defined correctly. Am I even like importing correctly? I don't know if I am. Let's see. If I do this. Yeah, no, I don't think I'm importing this correctly. It doesn't use of undeclared. Okay. Maybe I need to import like EVP or something. Oh, there we go. That works. Very nice. So EVP, this CT, I don't even know what this is, but okay. An RSA key can be generated simply like this. P key equals EVP RSA gen, and bits is 4096. This is the number of bits. Okay. Interesting. And RSA, okay, so I think this is supposed to be, let me just copy this code I see over here. So we have PKey null, and then we do this null, and then we initialize this, generate, give this pointer and this address, and then we free. Is this mallocing something? I wonder how and see if you like malloc something, right? Hypothetically, inside a function. Like, how do you know to clear that? You know what I mean? Like in this pointer, right? I guess if you have a pointer, it has to be like mallocked, I guess, because it has to. If it's returning a pointer, it has to be a malloc, huh? It has to be on the heap. Wait, can you return a pointer from a function that is not from the heap? Yeah, the only scenario where that works is if you have a static or global variable. So like, that's interesting. So okay, so we have this. What is this key now? So what can I do with this key? With key generation parameters, parameter one. Okay, so this is a private key. And what do I do with it? RSA. Let me search this up. ePair RSA CAPI docs. Maybe this is actually in the man pages. Generation of RSA private key. RSA key management, signing verification. Yeah. That's basically it. How do you do this? Okay. Can be converted between prints out. I can use my new TLDR, open SSL, or say. If it has it, that is. Okay. Generate a private key and re-encrypt it with the output file. Generate the corresponding public key from private key using RSA. Generate a self-signed certificate valid from a specific number of days. Convert certificate yada yada yada. Let's go here. I actually don't know if I need this yet. I probably create content for key generation. Actually, wait, maybe I do. Private key.pem. I still need to understand how this works. Because right now, what I'm trying to do is we have this transaction, and to validate this transaction, we basically have to like use public key to validate it? Question mark. So we have this. Yeah, this all works fine for now. To validate it, so for each individual transaction, how this works. So let's just write this down. It'd be like Alice gives Bob 5 coins. How do you validate this? To validate this transaction, go traverse the entire chain to see if Alice has 5 coins, and then do the same thing for Bob. Or no, actually, you don't need to do for Bob. You just need to check for Alice's blockchain if she has that money, and then you need to actually let's read the white paper. I'm gonna transition to my other screen if I can, but yeah, should be okay. Have this. Yeah, I can transition here. There we go. Oh. So we have this stuff. We don't care about this stuff yet. Timestamp server transactions. Yeah. So we define a transaction as a chain of digital signatures. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction to the public key of the next owner and adding these to the end of the coin. Payee can verify the signatures to verify the chain of ownership. What did they mean by this? We define an electronic coin as a chain of digital signatures. Each owner transfers the coin to the next by digitally sending a hash of the previous transaction and the public key of the next owner. Okay. Owner wants public key. Hash. We get the hash. Owner wants public key. Owner zero's signature. Verify. And then owner wants private key, signs owner one signature. Wait. So this is owner 2. This is the hash. They go here. They verify this, sign this. I don't get it. Problem of course is the pay can't verify that one of the owners did not double spend the coin. A common solution is authority. After each transaction, the coin must be returned to the mint to issue a new coin. and only coins issued directly from the mint are trusted not to be double spent. One of the solutions, the fate of the entire money depends on the company running the mint, with every transaction having to go through them, just like a bank. So yeah, this is like the double spending problem. I don't think solution we propose begins with a timestamp server, and it works by taking a hash of a block of items to be timestamped and widely published the hash, such as in that vein. Okay. So this is like a blockchain. Um, Again, so maybe this transaction verification process doesn't have anything to do with checking for double spending. This person just like uses their public key, signs a hash, and then that moves to the next one, and then the owner wants private keys used to sign it. I don't really get it. I don't really get how this works. Maybe I should ask good old Gemini or something. Let's actually read it once more just to make sure. We define an electronic coin as a chain of digital signatures. Each owner transfers the coin to the next by digitally signing the hash of the previous transaction, the public key of the next owner. Huh. I don't get it. You have a hash. Did they explain the hash here? What is GMX, by the way? Oh. We don't care about this. Yeah, I don't get this. I need help with this. Hmm. Think of a coin as a digital list of send. You take the digital fingerprint of a previous transaction, the public address of the person you're paying. You sign that hash with a private key. So I'm assuming the first transaction is like the genesis or whatever. Imagine Alice is 1 BTC. She tries to be sneaky and spend the same 1 BTC in two places at once. No, okay. A massive random number, your secret pen, derived from the private key via elliptic curve cryptography. Before you sign your well-constructed points to a previous transaction ID. You You take your transaction data above and hash it to get a unique fingerprint. Whoa. Unspent transaction app model. Think of it, but as collected to show bills. Okay. I see. Oh, unspent transaction account. Okay, I see. Sees the number 50, subtracts 10. Scans the blockchain for all but okay. When you send a transaction, this is a mempool. I see. That's actually quite interesting. Someone has already used it, it's double spend rejected. Does the signature match the locking script? Oh, so math won't balance rejected. Nodes don't trust managers. So managers tries to include a fake transaction in a block to give them some free money. Let's see the math. Right, okay. Okay, I see. I see. So, so each transaction needs to be linked to a previous transaction. Sender, recipient, amount, transaction ID. Transaction ID. Transaction. So the way to validate. Hmm. That entire chain, it's like previous transactions. To see this, verify using public key if it has been signed by private key. And I think that's pretty much it. So right now, like for the private stuff, we have a sender, recipient, amount, and transaction ID. Let's open like Bitcoin. Wait, is this what is this? I don't understand how Bitcoin like can still like be updated. That part I still don't get. Oh. Wait, what? Wow. Anyways, question. Can BTC be updated? I see. Altcoin. What is this? I don't know. I don't really care. Anyways, I guess that kind of makes sense. So now I need to figure out how to implement this transaction thing. Okay. Let me go back. Sender, recipient, amount. And then it would have you specify signature. Input is the previous ID. It's like a chain. How does BTC or how does counterclausal amounts if your 10th transaction was for 1 ETH? Oh, I see. Okay. Um, all right, I get it. I'm gonna go back and then transition back. Oh, why is this not? Transition. So first I need to figure out. Okay, so first I need to figure out this asymmetric encryption thing, which I still don't know how to do because I don't know why it's like so hard to, you know, get out for that. But let's see. Um, let's see. Message plus hash plus sign. I'm gonna copy this code and see what the heck happens. It just looks a little too complicated for me to write myself. And I'm just gonna like hope that the other programmers are gonna write this because this is like a project right here. Generate a key pair. Okay. Hello, I sign. Hello. Easy clap. Sign this. Sign with the private key. Verify with the public key. If valid is yes, let's know. Okay. A transaction. Maybe I should remove this. Undefined reference. Oh. Do I have to like import this with something? Okay, I see. Okay, so I think I need to do G++ transaction testing L crypto. Okay, there we go. So, I mean, I guess this kind of makes sense. Message assigned generate. So, what does this even do? Generate RSA key. This is the previous one we did. If this didn't work, null pointer. Keygen init CTX. Okay, this makes sense. So this is a 2048 bits. If I do 2048 divided by 8, that's 256 bytes. Okay. This is the public key. Generate key. Okay, so we have a key over here, and then we have a signed message with a private key. New signature init. I just sign update. Signature resize. Verify signature. Public key constant. Okay, so we generate this, which is the key pair, message, auto signature, signed message with a key pair, and verify signature with a key pair. What the heck is this? I don't get it. What is this key pair? I want to see this. Is key pair like a string or something? What is? It's an EVP key. What happens if I just print it? Okay. So is that my public or private key? What is that? Oh no, that's the address, because key pair is an address? No. What? Oh, the verified signature is giving the location. So do I have to dereference this? What then? Oh. Auto, I don't know, equals dereference key pair. What? Incomplete type. Key pair dot, or I don't know, like how do you I see. How hard is it to write my own RSA? I want to see what the simple RSA would do. RSA needs two prime numbers modulus quotient public exponent. Fast modular exponentiation. Let's try this. Maybe this will be a little bit better for me. Hardcoded parameters, the PQ, private exponent message, sign with private key, signature mod X, message, exponent, mod, verify with E. Oh, I see. So E and then, okay. What does this do? Result is one base mod, base percentage equals mod. while this... Wow, this is just some math stuff. I have no idea how this works. But now at least this makes sense. So, like, um, how do you... I see. Uh, Hmm. So in this transaction, we basically need a over here, instead of sender recipient amount transaction ID, we need the previous transaction, if I understand it. Let me see. Okay. Let me see. No sender or amount. Inputs and outputs. The idea of the transaction where you receive the money and one transaction can have multiple outputs. I see. So we don't have sender. We have recipient. We do have an amount. Um, transaction, input, self dot output, and then lock time. Oh yeah, there is a lock time as well. Hmm. TX ID. Recipient, amount, transaction ID. These are all the same. I don't think we need the lock time for now. What are these outputs though? Input, previous text, index, signature. I see. Yeah, it's a little hard. I don't know. I'm probably like gonna work on this just offline because it's just a lot of research and a lot more just like learning with actual programming. So I'm probably gonna stop doing this on stream. I'm gonna do more like coding problems on stream. Like I have uh I have where is it? Hold on, let me change my screen. Maybe? Uh yeah, over here I have yeah, I have hacker rank, which I can do. I can do deep ML, I can do neat code. And I also have like CPP quiz, learncpp.com, and stuff like that. So I'm probably just gonna do more of that on stream because like working on this project is like much more research, and yeah, I just need to learn a lot of stuff to do it. So